Alright, so in this video we're going to take a look at how we can use the enthalpy of reaction and stoichiometry to figure out how much heat is either released or absorbed by a reaction given a certain mass of it. So we can see in this case that we're dealing with the reaction of magnesium metal with oxygen gas forming magnesium oxide. And as you can see that there's a delta H reaction associated with that of negative 1,204 kilojoules per mole. So the first part of this question asks whether it's exothermic or endothermic. Okay, this all comes down to the sign of the delta H of reaction here. Given that it's negative, that means heat is released or evolved by the reaction, and therefore we would say that this reaction is clearly exothermic. The second part here, part B, calculate the amount of heat released when 5.5 grams of solid magnesium oxide is formed in the reaction. This is where the stoichiometry comes in. You can see that if we look at the reaction right now, we know that there's negative 1,204 kilojoules for 2 moles of magnesium oxide formed. One of the important things to remember about this kilojoules per mole right here is that that mole is actually not 1 mole. It's the moles for the equation as written. Okay, so we'll deal with that in 1 second. So when we go through to calculate this, what we would say is, all right, 5.5 grams of magnesium oxide. That's what we're dealing with here as a start. And when we go to set that up, first thing we're going to do is turn it into moles, sort of typical stoichiometry step. Right, so 1 mole over, and the molar mass of this 40.30 grams. Now we need to take that, and we're in moles of magnesium oxide right now. So now what I'm going to do is set it up using the delta H of reaction, and I'm simply going to say, well, there's negative 1,204 kilojoules per 2 moles of magnesium oxide. So when we go through and cancel these out, moles magnesium oxide, moles, grams magnesium oxide, grams, we are left in units of kilojoules here, and we calculate that through. We're going to get negative 82 kilojoules. So you can either write this as negative 82 kilojoules, which means 82 kilojoules of heat is released or evolved, or if you wanted to sort of drop the negative and write it as a positive, you can, but you have to denote that you know that that heat is being released, that this is an exothermic reaction. So you could say 82 kilojoules evolved or released. Either one of those would work to denote that you understand that realistically it's negative and this is an exothermic reaction. Okay, so really the only steps with these is to make sure that when you do that delta H of reaction that you get the right conversion factor here from the coefficients in the equation.